JIC, which stands for Joint Industry Conference, standards were widely adopted in the electrical industry before the National Electrical Code, or NEC, became the primary code. Many older facilities and installations still follow JIC guidelines. JIC standards remain relevant in certain industrial settings, such as heavy manufacturing, where specialized equipment and machinery require unique electrical requirements. Some engineers and contractors prefer to incorporate JIC requirements as a form of conservatism. They believe it provides an extra layer of safety and compliance. In some cases, contracts may explicitly specify JIC compliance as a condition of the project. This is often found in older contracts or those involving legacy systems. Despite the NEC dominance, some individuals may not be aware that JIC standards are no longer considered the primary electrical code. Some jurisdictions may allow a combination of the NEC and JIC standards depending on the specific situation. While the NEC has largely superseded JIC standards, it's important to note that JIC guidelines can still be used as a supplementary reference or for specific industry applications. When encountering specifications that require JIC compliance, it's best to clarify the intent with the project stakeholders. Determine if it's essential for that particular project or an outdated requirement. If JIC compliance is necessary, ensure that the project design and construction meet both the NEC and JIC requirements. Consider the following points when evaluating the need for JIC compliance. Firstly, assess the age of the facility or system. Older installations may have been originally designed and built to JIC standards. Secondly, determine the specific industry. Certain industries, such as automotive manufacturing or heavy machinery, may still reference JIC standards for specific equipment or processes. Thirdly, review the contract documents. Explicit requirements for JIC compliance may be included in the project's specifications. Fourthly, consult with experienced engineers and contractors. They can provide insights into the historical context and practical implications of JIC requirements. Fifthly, examine the local regulations. Some jurisdictions may have specific interpretations or modifications to the NEC that incorporate aspects of JIC standards. Sixthly, analyze the equipment being used. Certain types of industrial equipment may be designed or certified to JIC standards. Seventhly, consider the safety implications. Evaluate whether adhering to JIC standards would provide an additional layer of safety beyond what the NEC requires. Eighthly, weigh the cost implications. Determine if JIC compliance would add significant cost to the project. Ninthly, assess the risk of non-compliance. Understand the potential consequences of not meeting JIC requirements if they are specified in the contract. Tenthly, document the decision-making process. Clearly record the rationale for either accepting or rejecting JIC compliance to provide a clear audit trail. JIC standards focus on the design and construction of industrial electrical equipment and control panels. The NEC covers a broader range of electrical installations, including residential, commercial, and industrial settings. JIC standards often provide more detailed requirements for specific types of industrial equipment, such as motor starters, control transformers, and disconnect switches. The NEC provides general requirements for electrical installations, but it may not always address the specific needs of industrial equipment. JIC standards emphasize the use of specific components and wiring methods that are designed to withstand the harsh conditions found in industrial environments. The NEC allows for a wider range of components and wiring methods, but it also requires compliance with specific safety standards. JIC standards require that control panels be clearly labeled with information about the equipment they control, the voltage and current ratings, and the safety precautions that should be followed. The NEC also requires labeling of electrical equipment, but the specific requirements may vary depending on the type of equipment. JIC standards address the grounding and bonding of industrial equipment to minimize the risk of electric shock and to prevent the buildup of static electricity. The NEC also includes requirements for grounding and bonding, but they may be more general in nature. JIC standards specify the types of enclosures that should be used to protect electrical equipment from dust, moisture, and other environmental factors. The NEC also addresses enclosure requirements, but the specific requirements may vary depending on the location and environment. JIC standards provide guidelines for the layout and wiring of control panels to ensure that they are easy to maintain and troubleshoot. The NEC does not provide specific guidelines for control panel layout, but it does require that electrical equipment be installed in a neat and workmanlike manner. JIC standards address the use of control circuits and interlocks to ensure that equipment operates safely and reliably. The NEC also includes requirements for control circuits, but they may be more general in nature. JIC standards provide guidance on the selection and installation of overcurrent protection devices such as fuses and circuit breakers. The NEC also includes requirements for overcurrent protection, but the specific requirements may vary depending on the type of equipment and the application. JIC standards emphasize the importance of proper documentation, including wiring diagrams, component lists, and operating instructions. The NEC also requires documentation of electrical installations, but the specific requirements may vary depending on the scope of the project. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is widely adopted by state and local governments, and it serves as the basis for electrical inspections and enforcement. The purpose of the NEC is to protect people and property from electrical hazards. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is divided into chapters, articles, and sections. Each section contains specific requirements for electrical installations. The NEC also includes tables and figures that provide additional information and guidance. The NEC is a complex document, and it can be difficult to understand and apply. However, it is essential for anyone who works with electrical systems to be familiar with the NEC. The NEC is not a design manual. It does not provide specific instructions on how to design an electrical system. Instead, it sets minimum safety standards that must be met. The NEC is constantly evolving to keep pace with new technologies and changing safety concerns. The NFPA regularly updates the NEC to reflect these changes. The NEC is a valuable resource for electricians, engineers, inspectors, and other professionals who work with electrical systems. It provides a framework for ensuring that electrical installations are safe and reliable. The NEC is not the only standard that applies to electrical installations. Other standards, such as those published by the Institute of Electrical and Electronics Engineers, or IEE, and the American National Standards Institute, or ANSI, may also be relevant. The NEC is a living document that is constantly being updated and revised. It is important to stay up to date on the latest changes to the NEC to ensure that electrical installations are safe and compliant. The NEC is an essential tool for protecting people and property from electrical hazards. By following the requirements of the NEC, we can create safer and more reliable electrical systems. Consider some of the NEC articles. NEC Article 90.1 covers the purpose of the NEC. NEC Article 110.3 covers the examination, identification, installation, and use of equipment. NEC Article 210 covers branch circuits. NEC Article 215 covers feeders. NEC Article 220 covers branch circuit, feeder, and service calculations. NEC Article 230 covers services. NEC Article 250 covers grounding and bonding. NEC Article 300 covers wiring methods. NEC Article 310 covers conductors for general wiring. NEC Article 400 covers flexible cords and cables. NEC Article 408 covers switchboards and panel boards. NEC Article 430 covers motors, motor circuits, and controllers. NEC Article 450 covers transformers and transformer volts. NEC Article 500 covers hazardous locations. NEC Article 517 covers healthcare facilities. NEC Article 600 covers electric signs and outline lighting. NEC Article 625 covers electric vehicle charging systems. NEC Article 690 covers solar photovoltaic systems.